Welcome to The Explainer. So today we're diving into a story about math, but it's way, way older than you're probably thinking. I mean, we're talking about something that could totally shake up our entire timeline of human intelligence.
When you think about ancient math, what pops into your head? For most of us, it's the Great Pyramids, right? I mean, the sheer precision of those things, built about 4,500 years ago, is mind-blowing. But what if I told you that's not even close to the beginning? What if the real story of complex math starts way earlier, like 20,000 years ago?
All right, so here's how we're going to tackle this. First, we'll look at the Pharaoh's Golden Rule, the amazing math of the Egyptians. Then, we'll jump way back to a 20,000-year-old mystery. After that, we'll try cracking the Bones code, look at a wild new theory about it being a prehistoric slide rule, and finally, uncover this lost logic of a base 12 system. Let's get into it. So, let's start with Egypt. We're talking about the period between 3000 and 300 BC. The Egyptians, they weren't just stacking stones, they were building an entire civilization, and the engine behind it all? It was math. But this wasn't some abstract theoretical stuff. No, this was a super practical toolkit for solving the real-world problems of a massive empire.
And their system was just incredibly effective. They used a base 10 system. Sound familiar? It let them do everything. They could resurvey farmland after the Nile flooded every year, they could manage taxes, trade, and of course build those unbelievable monuments we still see today. I mean, from basic algebra to tricky volume calculations, math was literally the engine running their society.
Okay, and this is where it gets really cool. This shows you just how precise they were. To get those perfect, iconic slopes on the pyramids, they had this concept called the secant. Think of it as the ratio of the run to the rise. I mean, that's basically a precursor to modern trigonometry. It's how they guaranteed those massive structures were built with mind-boggling accuracy. Their whole take on fractions was totally unique, too. So instead of writing a fraction like we would, say 3/4, they broke it down. They'd write it as a sum of simpler fractions, like 1/2 plus 1/4. We know this from ancient texts like the Rhind Papyrus, and it just shows this really deep, really practical grasp of how numbers work.
And get this, they even figured out pi. Their approximation was 3.16. That is just astonishingly close to the 3.14 we use now. So the big takeaway here is that the Egyptians were absolute masters of practical math. They set the bar incredibly high for what we thought was possible in the ancient world. Okay, so we've established that high bar, right? And that's exactly why what we're about to look at is so shocking. We need to go back in time now, and I mean way back, over 15,000 years before anyone even dreamed of building the first pyramid.
So what if the story of math is tens of thousands of years older than that? That question takes us away from the giant monuments of Egypt and brings us to this one single, pretty humble-looking object. It was found back in the 1950s, way up near a source of the Nile River in a place called Ishango.
And here it is, the Ishango bone. It's tiny, only about 10 centimeters long, but it's dated to around 20,000 years ago. And as you can see, its surface is covered in these mysterious, very deliberate-looking notches. So for decades, the huge question has been, are these just scratches, or are we looking at the world's oldest mathematical tool?
Yeah, this really lays out the puzzle for us. There are 168 notches in total, and they're not random at all. You can see they're laid out in 3 very distinct columns. Researchers call them G, M, and D. That's just French for left, middle, and right. So there are clear patterns here, you can't deny it. But the real mystery is, what do they actually mean?
I mean, for more than 50 years, you've had the smartest people, mathematicians, historians, you name it, staring at this thing, trying to figure out the logic. What was this Stone Age person trying to tell us?
Okay, so when you actually count the notches, some really weird patterns pop out. The left column, get this, it has all the prime numbers between 10 and 20. The middle column seems to have some kind of doubling going on. So naturally, the first theories were like, aha, it's some kind of arithmetic game in base 10. But that theory never quite fit. It just couldn't explain all the numbers.
So what if we've all been looking at this thing completely the wrong way? What if those columns aren't just separate lists of cool numbers?
This is where our researcher named Vladimir Pletzer comes in with a totally radical idea. He said, look, what if it's not a game? What if it's not a calendar? What if it's a calculator? Like a prehistoric slide rule, built on a mathematical logic that's completely different from ours.
And his theory breaks the whole code down into 3 super simple, kind of elegant steps. First, he says you have to forget base 10. This whole system is built on just 2 numbers, 3 and 4. Second, the other numbers in that middle column, they're just made by adding or doubling those base numbers. So like 7 is just 3 plus 4. And third, and this is the key, the outer columns aren't just lists. They're the answers to calculations you do with the middle column.
Okay, let me give you an example so you can see it in action. The theory says if you take a few numbers from that middle column, let's say 4, 8, and 9, and you add them up, what do you get? You get 21. Now look at the number right next to them in the right-hand column. It's 21. That's not a coincidence. This kind of thing happens again and again, which really suggests this was an intentional working calculator. So if this theory holds up, it means the Ashango people weren't counting like us at all. They weren't in a base 10 world. It's like they were speaking a totally different mathematical language.
Yeah, this whole system seems to point to a base 12 system for counting, built out of those smaller bases of 3 and 4. And I know, that probably sounds super weird to us, right? We're so locked into counting by tens.
But here's the thing, counting in bases other than 10 is actually pretty common, both in history and even today, especially in different parts of Africa. Some cultures count using the knuckles on their fingers, others base their systems on lunar cycles. The fact that these systems exist gives us really strong circumstantial evidence that a base 12 system 20,000 years ago, totally plausible.
I mean, people have come up with all these incredibly clever ways to count on their hands, using knuckles, parts of their fingers, different hand shapes to mean different numbers. The Ashango bone, it might just be the oldest physical proof we have of one of these unique, non-10-based ways of thinking.
So here's the bottom line. This one little object, 20,000 years old, just throws a huge wrench in our assumptions about our Stone Age ancestors. It suggests they were capable of abstract, systematic, mathematical thinking, tens of thousands of years earlier than we ever thought possible.
This thing, it's probably not just a tally stick. It could literally be the world's first pocket calculator. And that just makes you wonder, right? What other incredible signs of ancient intelligence are just sitting out there, hiding in plain sight, waiting for us to finally figure out how to read them?